This project was suggested by Psychraz in the comments. If you want to suggest your own, you can. Just put a comment down and I'll try to get to that one. Now, today's project is an auto fish feeder. So, what this is going to do is it has its own clock system in the Arduino Uno, which can be expanded upon. And basically, this whole flap thing will dump the food into here at a specific time. Now, of course, the design is not perfect because this is not a fishbowl and that is not part of a fishbowl, but this is the basic design which can be adapted to. And of course, in this demo, we're using push buttons as food. Anyway, let's give this a try. So, I've already set the specific time for when this is going to go off. And that's actually in 10 seconds according to what the Uno thinks is the time. So let's see. So you can see after the 10 seconds when I started it, it just dumped the food. Now, it seems a little anticlimactic now. Nothing is happening, but you'd sort of have to wait till the same time the next day for it to happen again. But there's your demo. Now, we'll go on to the computer for the rest of this explanation. The way this entire project works is first, you set the current time, because you're resetting a clock almost to the current time. Then it will count up until the time you set as the feeding time. It will lower the arm, which contains the food, and you can customize how far down that arm goes, and then it'll retract that arm right back up. And it'll repeat that every single day, as long as you want. So it's great for automating feeding your fish, because it's just such a simple task. Why can't you automate it? Anyway, so the first thing we need to do is include a library. And we're going to be including servo, because we're going to be using a servo motor. It's really the best thing to control the food arm thing. Now, next we're going to be setting a lot of variables, because there are a lot of things we need to keep track of. First, we'll make the feed angle. This is going to be the angle at which the arm will turn to release the food. Next, I'm going to make another integer called times fed today, and we're going to set that equal to 0. That's going to keep track of how many times we fed the fish today. Now, this is what the feeding time is going to be in. So we have a sort of unique way of writing this. This is going to be equal, well, it's a unique way of doing this. So we're going to be writing the hours and the minutes separately for the time, and it's also in 24-hour time. So you can see that I based this off of Psychraz's suggestion for me. What he wanted was this, and he feeds his fish at 4 p.m., and since it's in 24-hour time, it's 16, because that's 12 plus 4. Now you could, of course, customize those numbers. Now, here are this is for the current time. So, let's just say it's 1 o'clock, and then that 7 minutes have passed, and that the minute is almost up, because this is what we use in the example to get it going. So anyway, now we'll declare a servo motor. We'll initialize it, and the final variable we'll have to set at the top is one called last mill. And you'll see this used commonly for timers and things that involve time and milliseconds. It's just a way of counting, and it requires this variable. Next, in the setup, we're going to begin the serial monitor. It's optional, but it will be useful if you're trying to debug it if it's not working. So I would just recommend doing this. Next, we're going to set up the servo. So servo.attach, and we're going to attach it to pin 9. This is equivalent to pin mode, but just using this library. Next, we'll write to the servo motor and we'll set it to a default, which our default is going to be 20 degrees. Next, we have to make a function to feed this fish because we don't want to repeat the same code over and over again. So, what we'll do is we'll write a function, feed fish, and we'll write to the serial monitor, feeding, because just in case you want to make sure that it's feeding when it's supposed to be. Next, we'll write to the servo motor, and we shall say, you should set this to the feed angle, because this is what we set earlier up here, as the standard angle, and that will just be useful so we don't have to repeat this over and over again. Next, we'll delay for 1 second. This is sort of a standard for the servo library. If you're ever turning to a specific angle, you might not get there if you do less than a second, so I would just always recommend going for 1 second. But you can play around with it if you want. Next, we'll set it back to our default position. And finally, we'll wait 1 more second. Now, we're ready to make the real code. Inside the loop, we'll make a variable called mil count, which stands for millisecond count. And this is how we count milliseconds in Arduino. So what we could do instead is use the delay function, but this is less accurate, and it also pauses every different part of the program all at once. Millis runs in the background, so this is the best option really for anything. Next, what we're going to do is print to the serial monitor basically just the current time as well as the milliseconds. So to convert from these integers to a string, we're going to put them in the string function. Next, we're going to print out the minutes, and then we're going to print out the seconds. And after that, we're going to print out the milliseconds, which will be rapidly changing. Okay. I'll make some space down here for us. So next, we're getting into some of the logic. So this is what will repeat quite a bit. This is like the timing part of it. So we'll write if millisecond count minus last mil is greater than 1000. This is basically checking. This is the current. This is the amount of milliseconds passed since the program started. This is what it was the last time a second has passed. And if those subtracted, let's say just over 1 second's passed, and this is 0, then we would get a number greater than 1000, and that would register as 1 second having passed. Now we can write another if statement, and inside that we'll say if millisecond count minus last mil is greater than or equal to 2000. Now what we're doing here is we're going to make a couple of these where it will increment seconds further, because when this feed fish function runs, it will take a couple of seconds where this is not updating. So what we want to do is be able to register if more than a second has passed, if 2 seconds or 3 seconds have passed, then we're just going to add more seconds. So we're going to set last mil equal to millisecond count, and we're also going to increment the second counter by 1. Now what we can do is just copy this if statement, because we're going to be doing 3,000 and 4,000 milliseconds. And what's inside of these is just the same. It's just good measure. And then finally, you can just copy the content of this, because we're going to have an initial one too. Now, after that, we get into more of the time part of this code. So we'll set we'll check if seconds is equal to 60. So if currently 60 seconds have passed, then we'll increment minutes by 1, and we'll reset second back to 0. Similarly, we'll do the same for minutes. So if minutes equals 60, then we'll increment hours by 1, and we will also set minutes back to 0. And finally, we'll check if hours is equal to 24. Then we'll set the hours back to 1. And that should be it. As well as, okay, never mind. Now, the final logic of this code is actually pretty simple. We'll make another if statement. There are a lot of those in this program. And we'll check if the current hours is greater than the feed hour. So when we want the hour in which we want to feed the fish, and if the current minutes is greater than feed minutes, so when we want to feed the minutes of that hour when we want to feed the fish, and finally, if times fed today is equal to 0. Now, if all of these conditions are true, then we can feed the fish. And we'll also set times fed today equal to 1. That way, it won't feed the fish again today. And next, and the final part of this program is the reset of the time. So if times fed today is equal to 1, basically what we're doing here is we are resetting the time the next day. So we're not resetting it during the same day. We're resetting it during the next day. I find that to be the easiest way, because we're only feeding it once. Of course, you can adapt the code to feed the fish twice or more. But this is just how I made it, because this is what was requested. Alright, now, and we'll set this back to 0, so everything can happen again. Now, when we upload this, you can see that we have the Arduino, and it's just sitting there, because what we have to do is, in order for this to work, we'll have to set, if you want it to happen right away, then you have to set this to 15, 59, and 50, and then you just wait 10 seconds, and then you'll see that once this minute has passed, you'll get to this time, and then it's lowered, and the food's released.